All right, hello ATM. This is going to be a lesson on 4-9 class portion. I will preface it by saying it's going to be rather lengthy, but the end of the lesson is probably the most important part because it's going to be very similar to your homework. So make sure you watch the whole thing, okay? And take good notes. All right, so today's lesson is going into factoring in a lot more detail than 4-9 group did. They give us the definition of what we call a zero of a function, and they kind of explain it in 3 different ways: graphically, numerically, and algebraically. You should have your textbook or at least the notes from Google Classroom, so I'll let you read that on your own time, but I gave an example that I think might help you understand what a zero is. I can say x equals 4 is a zero of the function f of x equals 3x minus 2. Because when I take negative 4 and I substitute it in right here, when I take positive 4 and substitute it in, 3 times 4 is 12 minus 12, and I get 0. You get 0 as the output. So any number that when substituted into the function gets you 0 as the output, you call that number a zero of the function, okay? So that's just some vocabulary. All right, so the next part wants us to look at this polynomial x minus 1, x plus 5, and calculate p of negative 5. So I'm gonna do some of this in my head, but basically what we're doing is we're taking negative 5 and we're plugging it in for both x's. So negative 5 minus 1 is negative 6. Negative 5 plus 5 is 0. So p of negative 5, if I multiply negative 6 times 0, I get 0 as my answer, okay? If I plug in negative 3 minus 1 is negative 4. Negative 3 plus 5 is 2. So p of negative 3, if I plug in negative 3, I get negative 8, okay? Next one, if I plug negative 1 in here, negative 1 minus 1 is negative 2. And negative 1 plus 5 is 3. So if I plug negative 1 in, p of negative 1 gets me negative 6. Okay. I'm sorry, I just made a numerical error here. Negative 1 plus 5 is not 3, it's 4. And then if you multiply negative 2 times 4, that gets you negative 8. My apologies. All right, if I plug in positive 1, 1 minus 1 gets me 0. And then 1 plus 5 gets me 6. So p of 1 gets me 0, okay? Now notice for 2 of these problems, I got 0 as an answer, okay? This doesn't really tell you anything special. If you were to graph this in your calculator, you could know that negative 3, negative 8 is on the graph. That's all that tells you, okay? But knowing that this, when you get 0 as the answer, you can then say, therefore, negative 5 and positive 1 are zeros because they result in 0 as an output, okay? The others just give you a random point on the graph, which is fine too. Good information. Okay, moving forward, you can use your graphing calculator for this, but they do give us a table and they give us a graph already, so you don't really have to use your calculator unless you want to. They give us the equation, and this is a table, and if you were to plot those points, you get this parabola shape, okay? It says to list the factors. Well, guess what? That's the pieces of the equation. So x minus 1 is a factor, but x plus 5 is also a factor, okay? Now it says list the zeros. This is where the group portion from yesterday is going to come into play. In order to figure out what the zeros are, you have to ask yourself, what do I plug in here for x to get 0 overall for the full factor? So x minus 1 equals 0. You'd have to add 1. That means x equals 1 is a 0. And then what would you have to plug in here to get 0? It would also be negative 5. So notice that the zeros are the opposite signs of the factors. Now it says to list the x-intercepts of the graph. We actually just found them, but we're going to write them as ordered pairs. And you can also look at the graph too. There's negative 5, there's positive 1. So negative 5, 0, and positive 1, 0, okay? They're also in the table. Whenever you get 0 as a y value, those are going to be your zeros, and they're also going to be your x-intercepts, okay? Let's try another one just like that. This one is not factored. It's in standard form, so finding the factors is not necessarily easy. We're going to talk about that a little later in the lesson. But again, they give us a table, they give us a graph, so it goes right to saying list the zeros. So I'm going to look at my table. Wherever I have 0 as a y value, those are going to be my zeros. So I have negative 3 and positive 1. List the x-intercepts. Well, those are technically the same thing. Negative 3, 0, and positive 1, 0. And you can also see them on the graph, okay? Now it says use parts A and B above to write it in factored form, because this time they're giving us the problem in standard form as opposed to factored form. So remember from the previous problem, I'm going to put it in front of us here, the factors and the zeros are opposite signs. So if we know what the zeros are here, we're just going to switch the signs. So we can say this function can also be written as x plus 3 times x minus 1. All I did was I changed the signs. If I were to double distribute this, I should get this equation. If not, then I made a mistake. But you do, in case you want to try it. Okay, moving on. Now they're going to give us just an equation, no table, no graph, and ask us similar information. So given this equation, what are the zeros? Don't worry about the 2 in front, that doesn't do anything. So if you're just looking at the x minus 3, we would have positive 3 as a 0. We would also have positive 4 as a 0. That's because if I plug in 3, I get 0 for that parenthesis. If I plug in 4, I get 0 for that set of parentheses. That means my x-intercepts are at 3, 0 and 4, 0. Okay. For number 5, there's 3 separate sets of parentheses, so I'm going to have 3 different zeros, negative 5, negative 4, and positive 2. So my x-intercepts are at negative 5, 0, negative 4, 0, and positive 2, 0. Okay. I hope this is making sense and it's not too complicated so far. We're going to switch gears just a little bit and we're going to talk about factoring. Okay. From that previous question, number 3, remember number 3, they did not give it to us in factored form. So without the table and without the graph, how would you get the factored form? That's now what we're asking. Without the table and the graph, how would you know what these are? Okay. So the next thing we're going to talk about is factoring all the way back from Algebra 1. Okay. What you might remember is that you have to get 2 numbers that multiply to C, but also add to B. So I'm going to write this at the top. We've got x squared plus bx plus c, okay? We want to find 2 numbers that multiply to C, but at the same time add to your B value, okay? So I'm going to undo this multiplication and I have to figure out what 2 factors, if I were to double distribute these 2 factors, get me back up here, okay? So if it helps, you can write this above the problem, okay? But what we're going to do here is we have to find 2 numbers that multiply to 7, but at the same time add to 8, okay? And I just realized that I didn't really explain. I came up with these problems on my own. The last question that we did in the textbook was number 5. I really don't like the way that the textbook talks about factoring for questions 6 through about 14. So I made up my own questions and I think it's going to be a little more clear. So I'm not following the textbook right now, but I will go back to it. When you were in Algebra 1, your teacher might have created what's called a product sum chart, okay? Multiply means product. Add means sum, right? So we need two numbers that will multiply to C, which in this case is 7. And then they also at the same time have to add to the B value, which in this case is 8. So you want to think about what are your factors of 7? Well, 7's a prime number, so you can only do 7 times 1. And then over here you add those numbers together and it works. So that means my factored form must be x plus 7, x plus 1. Okay? I'm hoping you're realizing, oh yeah, I remember how to do this because it was covered in Algebra 1 and Algebra 2. Over here, we do have a -8, so again, make the chart if it helps. I'm not gonna do this for every problem, but if it helps you make the chart, okay? We have to figure out what multiplies to -8 but also adds to 2. I know that 4 times 2 is 8, right? But in order to get a -8, one of these has to be negative. So then I go over here and I ask myself, if I were to add the 4 and the 2 together, I get 6, right? But which one do I have to make negative to get a positive 2 as a result of the sum? It would have to be the -2. So I just found my two numbers, okay? So x plus 4 and x minus 2. That is now factored using product sum. Okay. If you want at this point, pause the video and try the rest of the problems on the screen to see if you can get them right. This one here, I know 8 times 5 is 40. I have to play with the signs a little bit, so I'm going to put the 8 and the 5 there. One of them has to be negative to get that -40, but when I add them together, I want to get -3, so that means the bigger number has to be negative. -8 times 5 gets me -40. -8 plus 5 gets me -3. Okay, let's try number 9. 24 has a lot of factors, but the two factors that work are going to be 12 and 2. 12 times 2 is 24. 12 plus 2 is 14. Sorry. All right, the next one. 6 actually has a lot of factors as well, and when people see 5, they automatically think 6 and 1. But be careful, if it was 6 and 1, one of them would have to be negative to get 5, and they should all be positive because everything's positive here. In this case, 2 and 3 are going to work. 2 times 3 is 6, 2 plus 3 is 5. Now, this one's similar. I specifically did this because you'll notice that when this number becomes negative, it's not 2 and 3 anymore. You're going to have to use 6 and 1, but because of this negative, one of them has to be negative. In order to get a positive 5, the smaller number has to be negative, and the bigger number can be positive. Okay? So I hope that you're re-familiarizing yourself with product sum. I'm going to go back to the textbook now. Number 12, they start with another practice problem. And this is why I don't like the textbook. They take 3 problems just to get through one type of factoring problem. So they say, can you get y squared as a product? Yes, you would write that as y times y. Then they say, take the c value and figure out all of your options. So I wrote them out here. -10 can be written as 1 times -10, -1 times 10, 2 times -5, -2 times 5. And then I added them all together, and the only one that actually works is this one. So then you would write y plus 2 and y minus 5, and that's your factored version. But I'm hoping that you guys found my method a little faster and a little easier. Okay, now number 15, you might remember in Algebra 1 and Algebra 2, when the a value is not 1, let me actually bring my previous slide back up here. Notice in front of the x squared, there is nothing. That's because a is 1 in this case. I didn't even bother to write a at the top because there is no a. It's technically 1, okay? But when there is an a, you're going to have to use what's called slide and divide. So you might not remember this, but here are the slide and divide steps. So pause the video and take good notes on those steps to help you. And I'm going to run through this problem right now. So we're going to slide the a over to the c and multiply them together. So this 2 gets slid over, it goes away, but it gets multiplied times the -20, so I get -40. Now I factor this using product sum, so just what we were doing on the previous pages. I have to figure out what multiplies to -40 and also adds to -3. We actually did one of these. It's going to be -8 and +5, okay? But you're not done here. And this is where a lot of students make mistakes. They stop at this point. But be careful. If you're doing slide and divide, you can't forget about that 2 that you slid over. Now you have to take that and divide it out. Okay? Reduce if you can. In some cases, you should be able to reduce. Sometimes you can't. So 8 divided by 2 turns into a 4. But in this case, I would leave the 5 over 2 as 5 over 2, and then I would move to the last step of my slide and divide steps. Slide any denominators back in front of the individual x's. So the x minus 4 stays the same, but then that becomes 2x plus 5. And that is now factored. Okay, so be familiar with slide and divide and make sure you're comfortable with it. Okay? All right, and here's where we get to the important part to help you with homework, okay? These are word problems that require you to be able to use these factoring skills and kind of use them in a word problem. So refer back to these questions when you go to do your homework. I'm going to start with the second paragraph here. If you make your living from growing produce, let's say apples, the more apples you grow, the more you can sell. So why not just plant 1,000,000 apple trees? Well, it's because you can't. You might have limited space and resources. If the trees are too densely planted, meaning if they don't have enough space, they compete with each other for resources, and each tree ends up producing less apples, okay? So too many trees could mean less apples, and it's pretty obvious that not enough trees means less apples as well. Hey, maybe it's useful to find the ideal number of apple trees to plant. So in one orchard, there are 50 trees, each of which produces 800 apples. So 50 trees, but each tree produces 800 apples. For every additional tree planted, the average output per tree drops by 10 apples. Bummer. How many additional trees should be planted to get the largest total number of apples? Well, that's a big question. That's a loaded question. So the textbook takes us through it step by step, okay? So if X more trees are planted, how many trees will there be total? Well, we started with 50 trees, and we're adding an unknown amount. So that's your answer for 16. We don't know how much we're adding, so it's just plus X. If the current yield per tree is 800, and it's going to go down by 10 for each new tree planted, what will the yield per tree be if 5 more trees are planted? Well, we're starting with 800 apples, and we're subtracting 10 per new tree planted. We don't know how many trees we're planting yet, but then they said if 5 more trees are planted. So I'm going to put in that 5. Okay, that means 50 less apples will be produced. So 800 minus 50 gets me 750 apples, and that's per tree. Okay. If the current yield per tree is 800 and will go down by 10 for each new tree planted, what will the yield per tree be if X more trees are planted? I actually already did that, because they specifically said 5 up here, but I wrote X so that you guys could see where that would be coming from, okay? So that was just an example, but this is for any number of trees that they're gonna plant extra. Okay, let's move on. I'm actually gonna keep that handy. The total number of apples produced will be the total number of trees times the yield per tree. Write a function t of x describing the total number of apples using your answers to questions 16 and 18. So I want to write an expression for the total number of apples. That's going to be t of x. But they say it will be the total number of trees, which we wrote for number 16 was 50 plus x, times the yield per tree. And that was from number 18, 800 minus 10x. Okay, so that's the answer for number 19. Okay, now it says find the x-intercepts. So this is where the beginning of the lesson comes into play. I'm going to take the 50 plus x and set that equal to 0 to find the intercept here. I would subtract 50 and get negative 50. And then I'm going to take the 800 minus 10x and set that equal to 0. Subtract the 800. This one's a little bit more work than the others. Divide by negative 10. And that gets us positive 80. So we have negative 50, 0 and 80, 0 as our intercepts. Okay, now let's talk about what those mean, okay? Number 21 says the graph of this function is a parabola that opens down, and parabolas are symmetric. Now, how did they know that that parabola was opening down? Well, if you were to type your original function into your graphing calculator, make sure you zoom way out, change your window so that you're zoomed way out, you would see the picture that I sketched here, okay? You have to make your x-axis go all the way to negative 50 at least, make your y-axis go all the way to 80, and then right now we are gonna figure out what that top point is, because it says that means the high point we are looking for has to be halfway between the x-intercepts. We want to know how many apple trees must be planted to be able to get the highest number of apples produced. So this is the point that we're interested in, okay? Now, we found the x-intercepts, and so my dotted line is exactly halfway between these x-intercepts. So I have to figure out the halfway point, okay? So I wrote off to the side, to find the vertex given the intercepts, add the intercepts together and divide by 2. So I'm going to take negative 50 plus 80 and divide it by 2, okay? Now if I do that math, that gets me 30 over 2, which is 15. That tells me that this x value right here is 15. That means that I would have to plant 15 more trees to get the maximum number of apples that I could possibly have, okay? So how many new trees should they plant? 15 trees. But it also says, and how many apples will be produced? So now we have to take the 15 and plug it back into our t of x equation. So it was 50 plus x and then 800 minus 10x. So I have to figure out what is t of 15. So 50 plus 15, 800 minus 10 times 15. I'm just going to use a calculator here. And that gets me 42,250 apples will be produced. That's the maximum number of apples that we can produce. And in order to get that many apples, you'd have to plant 15 more trees. All right, so I hope that makes sense. Please send me any questions that you have regarding especially this last portion, starting with number 16, because that's what your homework is on, a very similar question to this. So if you need to, watch the last 8 minutes or so of the video twice maybe, just so that you have a full understanding of it. And then feel free to email me or comment on the assignment if you have any questions. Thank you for watching. I'm sorry it was a little bit longer of a video, and we'll see you next time. Bye.